Recently, Kawasaki launched its latest prototype robot that resembles a hydrogen-fueled iron horse named CORLEO. This prototype was first introduced at EXPO 2025 in Osaka, Japan. Its debut sent shockwaves around the globe and even trended on several social media platforms, as the technology has reached new heights in the interaction between robots and humans. In fact, Kawasaki itself is no stranger to robotics. For example, in 1968, Kawasaki signed a licensing agreement with Unimation, an American robotics company, which then became the first step in the birth of Japan's first fully domestically produced industrial robot, the Kawasaki Unimate 2000. Now let's take a quick flashback. Starting from the 1960s, we'll review the history of robot development by Kawasaki. We'll journey through the era of hydraulic robot innovations that evolved into electric robots with series such as the Puma and EX100, along with global expansion and the development of cleanroom robots for the semiconductor industry, until finally, at the peak of the digital revolution and 21st century collaborative robotics, the innovative prototype of the Iron Horse robot, CORLEO, is born. Before we continue, please support us by hitting the like and subscribe buttons and turning on notifications so that we can keep our enthusiasm high for covering future technological developments. Kawasaki's journey into the world of robotics began in 1968 when the company established the Office for Promoting Domestic Production of Industrial Robots. Amid the rapid post-war economic growth in Japan, the automotive industry faced major challenges such as labor shortages and the need to boost productivity. Through collaboration with the American company Unimation, Kawasaki successfully created Japan's first domestically produced industrial robot, the Kawasaki Unimate 2000, which was introduced in 1969. This first robot was not merely an automatic machine. With its teaching playback system, it could learn work patterns directly from an operator. Although it initially operated on hydraulic power and had a relatively low payload capacity, this innovation paved the way for robot adoption on automotive production lines, a revolutionary step for an industry experiencing mass motorization. This was the moment when robots started replacing dangerous and labor-intensive tasks, marking the dawn of industrial robotics in the land of the rising sun. Entering the 1970s, Japan not only enjoyed extraordinary economic growth, but also faced new dynamics that forced the companies to innovate. The oil crises of 1973 and 1979 compelled industries to use energy more efficiently, prompting a shift from hydraulically powered robots to electrically powered ones. This technological evolution was exemplified by the introduction of robots like the Puma, a small robot featuring an electric system and the robot programming language VAL, Variable Assembly Language. Advances in servo motor technology and increased reliability in control systems enabled Kawasaki to develop larger and more precise robots. In the early 1980s, through in-house development, the E-Series and EX100 were introduced. These robots were specifically designed to meet the needs of the automotive industry, such as high-speed welding and assembly with better energy efficiency. Through close collaboration with automotive engineers, Kawasaki not only honed its mechanical and control capabilities, but also learned valuable lessons from real-world applications, proving that robots were no longer just futuristic ideas, but concrete solutions to production challenges. During the 1980s and 1990s, domestic success spurred Kawasaki to enter the international market. Facing trade pressures between Japan and the United States and the need to meet global standards, Kawasaki established its first representative office in Detroit, Motor City, in the United States, and gradually expanded into Europe with offices in Amsterdam, London, and even by setting up subsidiaries in Germany. In the American market, Kawasaki's robots were tested on the automotive production lines of major companies such as GM and Ford. Rigorous technical challenges had to be met, from performance evaluations to operator training in the United States. As a result, products like the X100 received positive acclaim and became symbols of Japanese robotic reliability and efficiency. This expansion not only enhanced Kawasaki's global image, but also solidified its position as a pioneer in delivering sophisticated, integrated automation systems. With the expansion of the digital world and the information technology revolution in the 1990s, the semiconductor and electronics industries began to soar. The demand for robots capable of operating in cleanroom environments, spaces free from dust and particulate contamination, increased significantly. To meet this need, Kawasaki entered the cleanroom arena, developing robots specifically designed for the assembly and handling of semiconductor wafers and liquid crystal panels. Through in-depth research and the use of electric servo motors, Kawasaki's cleanroom robots are capable of operating at high speeds with exceptional precision. This innovation helped the semiconductor industry meet global demands for speed and production efficiency, while also demonstrating that Kawasaki's technology not only adapted to automotive trends, but also excelled in the high-tech sector. Entering the 21st century, demographic changes and social challenges, such as the declining workforce due to an aging population, began to reshape industry paradigms. The emergence of collaborative robots, or cobots, addressed these challenges. Kawasaki pioneered this innovation with robots like Duaro, a dual-arm SCARA robot designed to work alongside humans without the need for cumbersome safety barriers. Kawasaki's collaborative robots embrace an easy-to-use approach, enabling users to effortlessly teach movement patterns through tablets or direct manipulation. This concept facilitates the adoption of robots across various industries, from small factories to complex assembly lines in large companies. Behind every innovation lies a fusion of advanced digital control, artificial intelligence, and the Internet of Things, IoT, creating a smart and adaptive automation ecosystem. Now, after half a century of innovation, Kawasaki continues to push boundaries. CORLEO is introduced with a concept that integrates the sophistication of robotic technology with a keen sensitivity to human movement and intent, creating a harmonious synergy between man and machine. This robot can be ridden just like an iron horse. It features a four-legged drive system, and it is equipped with sensors that integrate the rider's body movements with a dynamic control system, translating every weight shift and subtle motion into precise, natural responses from the machine. Consequently, every action of the rider, whether climbing steep inclines, traversing uneven terrain, or adapting to obstacles, is seamlessly synchronized with the robot's movement, creating perfect harmony between human and machine. Although still in the prototype phase, it is very likely that this technology will soon move toward commercialization and revolutionize off-road mobility. With the integration of advanced sensors, intuitive control systems, and environmentally friendly hydrogen power, CORLEO has the potential to transform personal transportation, bringing us one step closer to a future where the relationship between humans and machines is harmonious in every environment.